Hello folks, Candor here once again and welcome back. Today I was going to show you my bench power supply. Now you've probably seen this many times off, usually over there in the corner, just kind of hanging out by itself, not doing very much. But seeing how today is such a dreary and gloomy and rainy day, I thought today would be the perfect opportunity for me to give this a little cosmetic upgrade. But what this really is my homemade power supply test bench. And this is from a company called, I call it DROKing. I don't know if it's DROKing or DROKing or it's DROK. But what this is a numerical control voltage regulator, or basically a fancy way of saying just an adjustable buck converter, really, is really all it really is. But this one right here is rated up to 408 watts. It can output up to 80 volts, but that depends on what your input voltage is. And it can output up to 5.1 amps. And again, that depends on what your input voltage is. And I'll explain that just a little bit more here by saying that inside of this little container right here is an old HP laptop power brick, that I have basically disassembled, taken out of the plastic, and just inserted it into this case that I 3D printed. And it's rated for like 19.6 volts at like 6 or 7 amps or something like that. So I can actually, with this little device right here, I can pretty much have any voltage range that I want, from pretty much 0 all the way up to about 18 volts, because you're never going to get the same voltage out that you put into it. It's just what a buck converter does, and it's how they work. But I can do up to 5.1 amps of output. So that's a pretty decent little power supply, if you ask me. You know, it's got quite a bit of range. However, I am going to be upgrading this. I'm going to be working on a couple of projects, and quite frankly, I'm going to need one that's a little bit beefier than this. I've already ordered it, and when it comes in, I'm going to show you that one, because that one's kind of special. But because of me no longer needing this, I am going to donate this to a friend of mine who needs a benchtop power supply. But as I said, I want to give it a little upgrade cosmetically, because it just really doesn't look all that great. I've kind of done my own little janky upgrades to it here and there along the way, and it doesn't look as good as as it could, really. But the way this really works is, I've converted this over to banana clips, which makes it really nice. And all you do is you press your power button, and as you can see, the LED comes on. And I don't know if you can see it or not, but I am currently running this at, well, I have the output set for 2.10 volts and 0.4 amps. But you can see that I'm only pulling between 2.08 and 2.1 volts, because it's fluctuating just a little bit. But the amperage, even though I have this set for 0.4 amps, it's only drawing 0.007 amps. In other words, all this little LED right here is drawing is 0.7 amps, which basically the equivalent of 0.01 watts. So this little LED right here is running at like 1/100th of a watt at about 2 volts. Now, it's not going to draw any more than I can give it, but I can overdrive it and I can blow it up. But I just wanted to show you that even though I have my amperage set higher than what this is running at, this is going to show me exactly what it's actually pulling. And the little LED down here is actually pulling. And if you want to change your voltage, all you need to do is you just push the voltage button up here. And then your rotary encoder is a press switch as well. So you press it. And every time you press it, it will move. It'll move from the hundredths position to the tenths position to the single. And then you can just sit there and dial whatever voltage that you like. And again, you can see I can dial that back. And it's the same thing for the amperage. You would just dial whatever amperage that you were looking for at that particular point in time. And then when you're done, you simply push your power button and it goes back to off. So let me break this open here and I'll show you what's actually inside of this, and I'll explain what I'm going to do to it to make it look a little bit prettier. So hang on for a second. Okay, and through the magic of editing, here we are with it completely disassembled. And as you can tell, there's really not a whole lot of pieces to it. This is the main piece right here. This is the controller. And you have four connectors in the back. 2 are inputs and 2 are outputs. You have your positive input here. You have your negative input here. You have your negative output and your positive output right here. And this is actually kind of nice too, because it actually comes out, so you can actually wire it up and then plug it back in, which makes it so you don't have to sit there and kind of fiddle with it when it's already inside kind of tight and cramped spaces. Makes it real easy to get around to. But as you can see, there's really not a whole lot to it. It's just a little tiny board with just a little rotary encoder knob and some electronics that just control the voltage input from whatever power source that you are using. And as I said, I'm using an old HP laptop, and this one is rated at, as you can see, 19.5 volts at 7.69 amps. So this is a fairly decent power supply. So I can draw up to almost 8 amps off of this at around 19.5 volts if I were to come directly off of this power supply right here. But since I'm going through this controller, I can only draw up to 18 volts at 5.1 amps, which is one of the reasons why I'm kind of replacing this. But other than that, really, those are the only 2 main components for this whole thing. Between these 2 right here, you have an entire working power supply test bench power supply right there. And I do apologize, guys. Normally I try to do a little bit of scripting ahead of time to give me a better understanding of what I'm going to say, but this is one of these days where, it's just off the top of my head, and I just felt like doing something and didn't feel like wasting all the time of sitting down and trying to type out a whole script of what I was going to say to everybody. The only other thing that I did do, though, is I pulled one of these plugs. If you've never gone dumpster diving before, you really don't know what you're missing. I have pulled, I cannot tell you how many useful items. I think one of the most useful items I've ever pulled was a 10 milliwatt brand new laser tube out of a box from a dumpster years ago. But I just had this cord right here, and I thought it would be a really nice addition because it does have a little GFCI on it, and if something did happen, it just gave me a little bit of extra protection. And I just soldered that right onto the bottom of the board right here. And that's my input. I just cut off the other wires and just took the wires that I needed. That's my output. I did add a fan though, because sometimes when you're running at the higher voltages and the higher amperage, especially for extended periods of time, the board can get a little warm. And they actually do recommend that you kind of, for extended long hard runs, that you actually give it a little bit of cooling. But what I did do though is I had one of these little 10K potentiometers just laying around, and I put that in series here. The reason for that is because this way here, no matter what power supply that I'm using or what voltage that I'm supplying, rather than having to go and look and try to calculate what my resistance value should be for a resistor in order to keep my fan from burning up, I can just come over here and just quickly now just take a little screwdriver and just turn that little knob in the center, and I can adjust it on the fly. So even if I do, as I said, change my power supply to a smaller or a bigger one, I can very easily adjust the speed of the fan without having to worry about damaging the fan. You may or may not have to do that or want to do that. I did put some banana plugs in there. Originally, I had just pretty much a set of test leads that I cut the ends off of and just ran through the plastic housing over there. Which brings me to one of the main reason why I want to really upgrade this. In case you can't tell, the top of this, you can see where I manually tried to drill some holes. And I tried to make it look nice, but don't really care for that. You can also see that through the wonders of my absolute brilliant cutting work, I have cut out the world's most perfect hole in the side. No. So I didn't like that. I didn't like the idea of giving that to my friend in this condition. It just, it just doesn't look right, guys. Now on the back, this is where I kind of messed up a bit. Those holes I actually did incorporate with 3D printer, and I did actually manage to have to cut out a little bit more for the wire because it's so thick and so heavy, and I had to make a hole bigger, and as you can see, it doesn't really line up. And I really wish this autofocus would start working again, but another reason I wanted to make it look better is because I didn't like that hole. And also, you can see, again, I did incorporate holes on the side right here when I actually did the 3D printer work, and I somehow managed to goof that up as well. So, but this is where the test leads originally came out of, and I didn't like that, so I turned it over to banana clips. So what we're going to do is, we're going to get rid of this case altogether. We're not going to change too much with it, actually. But what we are going to do is, I printed a new one. And as you can see, the top looks a lot better. The fan is a little bit more professional looking. And in the back, rather than having the bare wire just come out the back, I thought what I would do is, I have a couple of these XT60 connectors. I'm just going to go through and I am going to insert an XT60 socket into the back of this, which is a really super tight fit. And because it's not really designed for panel mount, I'm just going to use a little bit of hot snot glue and pretty much just glue it in there so that we can just make a cable and just plug it in and unplug it as we need and make it a little bit easier for maneuvering around. The other thing that I did do, though, is, if you can see, I have these little notches. They're like little raised center pieces right here. The old one didn't have that. So basically what would happen is, when I actually put the power supply in, you can see there is nothing keeping it from going around, or from moving around on the inside. It was just sitting there, basically with the top of the case just resting on top of the edges, which isn't exactly the safest thing in the world, but it was only me using it, and I knew, and I wasn't moving it around much. But because I'm giving this to somebody else, and I'm not exactly sure where he's going to keep it, I know he has kids and pets, I went through and I put those little nubs in there, so now they fit right inside the holes right here, so it won't move. And once you put the top on, it's going to be locked in completely. So it's going to look a little nicer too. So this right here is all going to come off. This is going to get desoldered, and it will be attached to the other end of the X60 power plug right there. And I will just wire two little wires from here to the back of the X60 connector right there. And pretty much everything else is going to look almost exactly the same, really. Didn't really change the design too much of it. I kept it fairly much. I did soften the edges a little bit. I kind of made it a little bit more rounder, not as sharp. like I said, I know he does have kids, even though they're old enough to know better. It's safety first, And he does have pets and a cat and a dog, and, they might bump into things, but I did make it a little bit softer, and it looks a little nicer anyway. So I'm going to go back and I'm going to reassemble this, and when it's all done, we'll have a better working system. So hang on, folks. Okay, once again, through the magic of editing, we are done. I didn't want to bore you with the time that it took me to bring out my soldering station and break this all down and solder the wires, and quite frankly, having to do that with the camera in my way is a little bit awkward. But quickly, what I've done here is, right here are the two input cables that run from the mains voltage. And as I said before, I did connect them to the XT60 connector, which is right here. Right now I just have that super glued in place temporarily till I get some hot glue on that. These wires right here are running into the actual unit itself. So this is now supplying power to the head unit. And I now have the banana clips installed, and they are running right from the unit itself into the front of the banana clips, as you can see here. So now, if everything is connected properly, now that I've cleaned up the wires, I've shortened them, and I've made better connections, if I take the cable and plug it into the back, once I turn this on, we should have a working bench power supply. If I turn it on, that is. There we go. There. And see my handy dandy trusty multimeter over there. 2.099 volts, and I have 2.1 volts on the actual screen. So we are working, folks. We now have a fully functional bench power supply. So if any of you guys out there, or ladies for that matter, I'm not going to exclude any ladies out there because I know quite a few of you out there that are actually quite good at electronics. If anybody is looking for a cheap way to make a bench power supply for something that you need, if you happen to have an old laptop power supply or an old power brick that can supply the maximum amount of voltage and amperage that you're looking for, this may be the way to go. I will leave a link down below where I got this. It wasn't too expensive. I think it was only in the neighborhood of about $35. And for that small amount of time, I just used my 3D printer and just quickly made a box and a case for it. And once I get that all back together and all assembled nice and nice, and get the wires in there, it'll be a nice little unit. Of course, now I'm trying to fight it with the camera running. And then we just have to put screws in the bottom. Like so. Now the other one actually had rubber feet on the bottom. Little silicone rubber feet to keep it from slipping and sliding. I may actually do that again before I send it out. I don't know if I have any extras or not, but I think that if I do have some extras, I think I will put them on there for my buddy so that the unit doesn't slip and slide all over his bench. And apparently I missed the holes because, like an idiot, that's how I roll. Alright, well, I'll fix that in a minute. But as you can see, not everything that I do is actually working 100%. I am not a perfectionist. I do things that look good and work good. They don't always work out exactly the first time around, especially when on camera. But the basic premise is there. It will fit. I have test fitted this before. I do know that it does fit. It's just being finicky now that I'm on camera. But for about $35 and some spare parts that I had, you know, even the fan was a spare fan that I had laying around from an old computer component. I think, actually, to tell you the truth, I think that actually came out of an old security video camera recorder. But for, you know, just a couple of cheap little pieces and parts, I have a fully functional bench that I can just quickly unplug and take with me and put wherever I need to go. And it's been a good little unit. It has served me well. I've had no problems with it, other than the fact that, like I said, I'm just kind of outgrowing it a little bit, and I just needed something a little bit bigger. And in case anybody is wondering, that soldering station behind me right there, I actually have a video for that. At the end of this video, I'm going to put a link to the video so you can see that. I did a video on that one when I first bought it and took it out of the box. That has been another nice little unit. That is a soldering station and a hot workstation. And that thing has saved me so much money already. I have used that to repair several of my first 3D printer boards when the USB UART chip was blown and I needed to surface mount and replace a couple of those components. That has been an invaluable tool, and it has been working very well also. In case you haven't been able to tell, I am not a person who likes to spend an entirely large amount of money on things. I will spend the money if I feel, or, you know, if it's warranted, I will spend the money. But if I can find a cheaper alternative that is of, you know, decent quality, I would prefer to go that route as well, for obvious reasons. But I also like making things myself. To me, making something is more satisfying and more gratifying than going to the store and buying something off the shelf. Certain things I have to, but anything that I can make myself, I make myself. So I'm sorry that this wasn't exactly the greatest video in the world, but as I said, this was just a video I did off the top of my head, real quick. You know, I'm bored, it's raining outside, I really have nothing better to do, and I just figured this would be a perfect opportunity to catch up on some old work and, you know, give something a new facelift. And eventually I hope my buddy will appreciate the time and effort that I put into making this for him, and I'm sure he's going to get a lot of use out of this. And also, like I said before, when the new one comes in, I'll show you that one. That one is going to be quite unique. So once again, I'd like to thank everybody for tuning in and watching. I know I'm not the most fantastic YouTuber in the world, and you know, I'm just fairly starting out, but every time one of you people watch my videos, it makes me happy. So until next time, I hope to see you all again, and everybody stay safe and have a great day, guys. Bye-bye.